Welcome to part 3 of the computing history lecture. I'm going to probably go a little quickly through this because I want you to have time to do the worksheet during class. But we've talked about the beginning of computing history with mechanical devices. And of course, the abacus was one of the most early devices used for tabulating or calculating for mathematics. And from there, we jump to 1642 with Pascal and the Pascaline and the stepped reckoner with von Leibniz, both of which were purely mechanical devices, inaccurate, had too many movable parts, too many manufacturing issues. And from then we jump to electromechanical, Hermann Hollerith and the tabulating machine that he developed so that the Census Bureau could tabulate their data. So now we're dealing with electricity and maybe some moving parts and wiring, but electricity is coming into play with powering these machines. And then from then we had the Harvard Mark I, which was part of the World War II effort to do some intense calculations, I think, on ballistic missiles or ballistics, basically missile trajectories for the Navy. And so from there we moved into the first generation of computers, the Atanasoff-Berry computer or the ABC. Again, these things use electricity, they do some mathematical calculations, and moving from there, we have some other devices that come along. But most of these are basically glorified calculators. They don't really have the concept of a stored program in memory. We're going to find that they use things like vacuum tubes that generate a lot of heat. They weigh tons, they take up rooms and rooms and buildings, and they're very expensive. So really only the government can afford them. Maybe some very wealthy companies, but primarily government agencies or universities are able to afford them. So now we're going to jump into the last bit of this before we start doing some programming. And so we've talked about the abacus, Pascaline, stepped reckoner. Oh, I forgot the most important proposed mechanical device that was never built, the difference engine, and also the other one, the analytical engine, those with Babbage and Ada Byron, and those are very, very important. So you need to look at the resources that were online that I pointed you to regarding those. Babbage was very forward thinking, so was Byron. And they really sort of came up with the idea for the modern computer. So then we moved to the tabulating machine, the Mark I, the ABC. Oh, and I forgot the ENIAC, which was one of the first generation computers. Again, large, primarily for math. I think it had a lot of vacuum tubes, took up a lot of space, very expensive, weighed tons. So next we're going to go to the idea, getting a little more into what's going to evolve into the modern day computer. We have someone who, like Byron, thinks that you've got to have a way to have memory, to have instructions that are followed, that are held in memory. And so Alan Turing is going to come up with an idea. He's not going to necessarily build anything, but he's going to propose the idea and publish the idea in the 30s that the device that's going to use to calculate is not only going to be a calculator, it's going to have stored instructions that are going to be stored in a memory unit. And he called it the universal machine. Okay, so that's just an idea. Well, not too long after that, in 1945, von Neumann proposes the same type of thing, the idea of a stored program, and he comes up with something called the central processing unit. That's where, in his mind, in some type of device that's going to be able to make decisions and do calculations, the program is going to reside in this central processing unit or CPU, which that is exactly what we call the processor with the memory today in computers, the CPU. Now he's going to join up with Mauchly and Eckert, and they're going to build a big computing device called the EDVAC, and that's going to use a paper tape to store program instructions in binary. So we're getting a little closer to the idea of a program instructions more than just a glorified calculator for these devices. And so the tape acts as memory. Now we're talking about getting a little bit more recognizable to today's computer. So Mauchly and Eckert have done lots of different things, and they are going to go on and do another machine called the UNIVAC around 1951 that's going to have the ability to use tape or punch cards or something to sort of temporarily store the program instructions. Now these things use lots of vacuum tubes. They were large, they were very expensive, generated a lot of heat. And when they needed to be reprogrammed, sometimes even though the program was on paper, they would have to go rewire and move vacuum tubes and things like that to enable the program to run. So you still have this idea that yes, it's a computer, but part of the programming is rewiring or moving parts around in order to get the program to do what you want it to do. Now, around 1947, we have the breakthrough with the development of the transistor at Bell Labs by Shockley, Bardeen, and Brattain, and that is going to change how these huge vacuum tube devices are functioning or built. They're going to come down in size, down in cost. We're going to get rid of all the heat with the vacuum tubes. We're going to replace the vacuum tubes with transistors, and now the computers are going to be much, much faster. They're going to cost less. And now, instead of using paper tape or punch cards, we're going to store programs on magnetic tape. And that's going to be a big breakthrough because you can get a lot of information on a magnetic tape, much more than you could on punch cards or on paper tape. So now you can have larger programs, more programs, easier to put programs in and out of memory by reading the mag tape instead of having a paper tape that has to feed through while somebody's changing wiring around. So all of that's going away, and we're getting even closer to what we're going to recognize as a computer. And these are our second generation computers, the ones that are going to use transistors and magnetic tape. But because we've got now this capacity, they're a little less expensive, they can be more useful, more businesses and organizations can have them, it's a really difficult thing to program in binary. So if we want to have more people who can program these things, we've got to have languages, high-level languages, something other than binary or assembler or hexadecimal, which are low-level languages. We've got to have more English-like languages, and so there are people who start working on developing these that the computer will then translate into binary so it can execute instructions, but we have this buffer between the person and the binary that the computer needs, this English-like high-level language that allows the person, the computer, to be more, the programmer, sorry, to be more, oops, I think I jumped down here, to be more productive because they can write it in an English-like way and write it without a lot of errors, and then the machine can translate it down to binary. So we have the main figure for this is Grace Hopper, who ended up being an admiral in the Navy, died not too long ago actually. And she helped develop the most popular first high-level language for businesses called COBOL. So a few other languages, and she worked for the Department of Defense. They were big into developing these languages because they had a lot of uses for these big computing devices from the Mark I to whatever. They saw the potential in computers for them. So Grace Hopper helped develop COBOL. The DoD also developed Fortran and Ada. So then they named Ada after Ada Byron. So now we've got easier to use languages, and now we're going to jump again in the 60s. We're going to go from transistors to integrated circuits. Again, smaller units that are faster, that can handle more, that can process more, that are cheaper. So the computers are going to become faster, less expensive, smaller. And Noyce and Kilby were working independently. They were two separate guys working independently, but right around 1961, they both came up with the idea of the integrated circuit. Then in 1970, we're going to jump now to our fourth generation computers where we're going to have microprocessors. Noyce actually went on to found Intel, and I think he lived up until 1990. So in 1970, Hoff, who was an engineer for Intel, invented the microprocessor, and now you can put an entire CPU on one chip, which had not been able to be done before. So now you really have a desktop box that an individual can buy. It's more affordable, and we've got the birth of the personal computer. Then in 76, another milestone is Steve Jobs and Wozniak are going to create the first Apple computer for home use. So that's kind of the whirlwind tour. We've gone from the dawn of time up until about Apple, and of course you've seen that evolve into personal computers, laptops, and I didn't even talk about smartphones and tablets, which are a whole additional generation of devices. So what we're going to do is we're going to have a quiz toward the end of the week on all the material that we've talked about for computing history. We're going to create 2 applications, Hello World and an interactive computing history quiz. And so for today, what you're going to do is you're going to start gathering the information you're going to need to put into Visual Basic to provide pictures and text and all this good information for the people that are going to press the various command buttons we're going to put on your little form. So what you need to do is, there are roughly 10 milestones that I've identified, and you're going to need to get 2 pictures per milestone. Get any pictures from the web, pictures of the Pascaline, the ENIAC, whatever. And then you're going to need to write a question about each device that would kind of pique the user's curiosity. And then you're going to have to write 3 sentences about that particular milestone and why it was important, and then how you're going to kind of answer your own question. So for example, one milestone is the Pascaline. So we can get 2 pictures off the internet and save them on our student drives or flash drives of the Pascaline. And then one question you might propose about the Pascaline is, what mechanical device for adding, for addition, was created in 1642? And then you're going to write 3 sentences to answer your question and kind of explain to the user what the Pascaline is. The Pascaline was invented by Blaise Pascal in 1642 to perform addition. It used gears much like a clock. It was unreliable due to manufacturing issues. So that's kind of your pattern, and that's the worksheet that I sent you. It has the milestones on there, and it has the Pascal example, and that's kind of what you need to follow. So take the rest of class, work on that. Save your pictures somewhere that you can get to them. I don't need those. But email me your completed Word document by the end of class today for a grade. Or, as far as you got, email it to me, and the rest will be for homework. I will try to catch up with you guys live one day this week and see how you're doing. But let's plan on getting this done today, possibly spending a little bit of time on it tomorrow, and then jumping right in and doing our first application.